Sup everybody, it's Dr. J, and today we are going to talk about how to find empirical formulas. So let's talk about some chemistry. Alright, so to remind everybody, empirical formulas are basically the smallest whole number ratio of elements in a formula, okay? So basically, let's look at an example. I love examples. Empirical formula for sulfur monoxide, SO, and disulfur dioxide, S2O2, are the same, alright? So remember, empirical formulas are going to be the most simple. Think of it as that, right? The simple chemical formula. So in this case, right, if you make this disulfur dioxide simple, right, to where it's just telling me what it has, that's going to be SO. So that's the reason why they can have the same empirical formula. Now, we need to realize that they will have different molecular formulas, right, because they're different compounds. So for disulfur dioxide, sulfur monoxide, we need to just remember that, right? So when it comes to finding empirical formula, well, let's go over how we're going to do that today. So let's say that we have 60% of a compound that's like carbon, right? And in this compound, we have hydrogen, and it's comprised of 4.48%. And then we have some oxygen too, which is 35.52%. Okay, so we know the percentages of our carbon, hydrogen, and oxygen elements in this compound. I need to find the empirical formula. All right, so how are we going to find the empirical formula? All right, so I'm going to basically give you step by step how you always find the empirical formula. Okay, so the first thing you want to do is convert your mass percent to grams of the element. All right, so basically where it's like 100 total grams of a sample. So what I mean by that is, for instance, let's say we're looking at carbon here. Basically, I want to set it up to where my 60% is just 60 grams of carbon over 100 grams. Okay, and then we times this by 100 grams to cancel out our 100 grams here, leaving us with 60 grams of carbon. All right, and we're going to do this with all our percentages. So I'm going to do this with hydrogen, right? 4.48 grams of carbon over 100 grams times 100 grams to cancel those out. And then oxygen, 35.52 grams of oxygen over 100 grams, cancel that out. All right, so essentially this is like an extra step. If you are able to just convert it, 60% is 60 grams, 4.48 grams, 35.52 is this grams here. All right, so you're able to easily do that. I just wanted to show you how we went from percentage to grams. All right, but automatically you could do that in your head, just converting it to grams. Now from here, here's the next step. Once we have our percentage to grams, we then need to convert our grams to, you guessed it, moles. Okay, so this is the reason why I said, man, you got to know how to convert. In this case, you got to know how to convert grams to moles. If you don't know how to convert grams to moles, you know, this is probably going to be throwing you off. Okay, but let's just go over this. 60 grams of carbon, this is what we have here, times our conversion factor. In this case, our conversion factor is the molar mass for carbon. So we need to look at our periodic table. And once we look at our periodic table, we're going to see that right in our periodic table, there's 12 grams of carbon. So we need to understand that for every 1 mole of carbon, there's 12 grams of carbon there, right? Molar mass. Okay. So grams cancel out. We're left with moles on top. That's going to give me 4.9 moles of carbon. And basically, we're going to do this for all of our elements. Hydrogen, I will convert to moles, right? So that's going to be 1 mole of hydrogen and 1 gram. So that's going to be 4.44 moles of hydrogen. And then we're going to have our molar mass of oxygen. So in this case, 35.52 grams of oxygen times our molar mass, which is 1 mole of oxygen over 16 grams of oxygen here. All right, and once again, we're getting all of our numbers from our periodic table. Okay, so definitely make sure that you have a periodic table on hand. And then from here, we're just going to divide, and I'm going to get 2.2 moles of oxygen. So far, we've converted our percentage to grams, and then we converted our grams to moles. What do we do from here, right, to find our empirical formula? We now need to divide each number of moles by the smallest to get to a small number ratio. So in this case, let's look at our moles we have. Like I mentioned before, we have 4.996 moles of carbon, 4.44 moles of hydrogen, 2.22 moles of oxygen. Okay, so I put it as subscripts because basically that's what we're finding here. We're really finding the formula, so I just put it here. You don't necessarily have to do that, but it's just a good, visual representation of what we're finding here. So now we need to divide each number of our moles by the smallest number. So in this case, the smallest number of the mole is oxygen at 2.2. So I'm going to divide my carbon 4.996 by 2.220. All right, so that's going to be 2.25. Okay, so I put it here because this is ultimately what the formula will be for my carbon. Next is hydrogen, so I'm going to do 4.4 divided by 2.2. That's going to be 2 for hydrogen, and then of course oxygen, 2.2 divided by 2.2. That's going to be 1. All right, anything divided by itself is 1. So now we've just determined the smallest number ratio. Usually this will be it. However, if you have in this case, decimal here, you can't have decimals and fractions. We went over that with some theories, like I mentioned before. So you can't have decimals for our chemical formulas. All right, you can't have decimals, fractions, etc. You can't have part of something. You got to have a whole. So in order for this to become a whole number, right, a whole ratio, we're going to multiply our entire compound by a factor to make sure that all of our numbers will be whole. All right. So in order to do that, for 2.25, I will multiply this by 4, right? Because I need to understand, like, we got to think of this as ratios, right? Or you can think of it as percentages, right? 25%, if you got 25%, you need 4 more to get to 100%, right? Or a whole. So I'm going to multiply my 2.25 by 4. Now, you need to understand too as well, you have to multiply your entire formula by 4, not just 1. So you can't just multiply 2.25 by 4 and then leave it as that. You cannot do that. You have to multiply your 2.25 by 4, your hydrogen by 4, and then your oxygen by 4. Okay. So once you do that, right, this is what we're going to get here. 2.25 times 4 is 9. So now our carbon 2.25 becomes C9. Hydrogen 2 times 4 will become 8. And then the oxygen, right, 4 times 1 will become 4. So this is now my empirical formula for this particular compound. All right. And then here's just a little quick thing. You could take a screenshot of this, whatever you want to do. Take a picture of this. Basically, if you're not good at, figuring out, 25%, you need to multiply it by 4, you can use this right here. Right? So basically, this is showing if you got any type of decimal for your subscript, like you have to multiply it by this numbers over here. So if you had like 2.25 something, you multiply by 4. Or if this was like 2.4, right, I would have to multiply it by 5, right, because we're trying to get to 100%. If it was at 20, right, 2.2, you will multiply by 5, etc. All right. So this definitely can be helpful if you need some help trying to get it to a whole number here. And this is how we are going to calculate our empirical formulas.